Internet of Things and computing everywhere are nowadays relevant technological scenarios for AI, and industries are playing a crucial role in this field. Let's hear the point of view of an expert.
Hi, I am Danilo Pau, Technical Director, IEEE and ST Fellow, responsible for the development of artificial intelligence tool for microcontrollers and sensors in system research and application in ST Microelectronics based in Agrate Brianza, Italy.
What is STM Microelectronics doing in AI?
To give you a bit of context, ST Microelectronics produces and sells a lot of microcontrollers. STM32 in the domain of Internet of Things and SPC5 family in the context of automotive application. Therefore, when approaching to artificial intelligence, one basic consideration and question was, is that a trendy subject or a technological singularity? Well, we came to a conclusion that was the latter, and it changed also the way allows to shape application. Therefore, we introduced a methodology composed by 5 steps in the domain of supervised deep learning. The first step is to conceive an application. Therefore, it means to select sensors that produce data that feed the application. The second step is to acquire enough data and clean them, properly label them, so that they are ready for the third step. In the third step, usually an AI application developer is used to design, to create a neural network topology and to train it. Therefore, it uses well-popular deep learning tools such as Keras, TensorFlow, PyTorch, and typically they are exported in formats which are used to run neural network on various devices. In the fourth step, we introduced there is a need to deploy such a pre-trained neural network on microcontrollers. Therefore, to automatically deploy them and validate on company-made microcontrollers, STM32 and SPC5, we introduced a unique technology which automatically translate them into efficient code and libraries that run with scarce resources on those microcontrollers. The technology has been embodied in 2 tools that have been made public and made available to the developer community, and they are called STM32Cube.ai and SPC5Studio.ai. In the fifth step, the library generated by those tools are deployed on the microcontroller, and therefore field trials on the application can run in order to validate on the field then. Those tools have been conceived in such a way they satisfy 4 basic requirements. The first is to be interoperable with publicly available deep learning tool, such as the one I mentioned, Keras, TensorFlow, and the one that allows to create on NX representation. It's important because the interoperability topic, because through a well-defined standard format, it is possible for those tools to export pre-trained neural network and for our technology to import and do the processing. The second requirement is the capability to generate code that can feed any integrated development environment the embedded software community is willing to use. There are many IDEs around the community which is used to use them, and therefore we need to interoperate once again with them. How? To generating ANSYS code. The third requirement is to be agnostic on any application, which means to be agnostic on the selection of the sensor and the real-time operating system. In such a way, we give the freedom to the developer to shape, to define, to conceive the application as they wish. The fourth requirement is to be capable to use the microcontroller as an artificial intelligence hub. What does it mean? It means the capability to instantiate multiple networks, neural networks, and to run them independently from any software or hardware scheduler, so that the microcontroller can run them serving different sensors. And the output is the output to be used on SPC5 and STM32 microcontrollers.
What do you think is limiting broad AI development?
AI developers typically uncraft neural network topologies in order to fit them on resource-limited microcontrollers. One of the major challenges I see in the future is to allow them to use tools that automatically generate neural network topologies and optimize their hyperparameter simultaneously in line with the constraints posed by the microcontrollers. So what we need in the future are neural architecture search / hyperparameter optimization tools guided by resource constraints in order to simultaneously allow the design of the network accurate and deployable on microcontrollers.
After AI in microcontrollers, what do you think the next challenge will be?
After artificial intelligence on microcontrollers, the next big trend will be in-sensor artificial intelligence computing, which means to bring artificial intelligence in the sensor itself, which implies to satisfy the following requirement. Be low complex as the sensor itself is, therefore be integrable on the same die, sharing the same technological node, and be as low power as the sensor it is, which imply clearly to be in the microwatt power consumption envelope.
So, the future of AI is bright and low power. Thank you, Danilo.